different disks at a time. So this determines how many chunklets at a time will be allocated for the CPG. So it's not like a gig, just kind of on the fly. It's going to allocate 32 gig at a time or 64 gig at a time, chunklets. All right. So now what happens when the chunklets are used? Let's say you got volumes created using a CPG, so we're allocating 64 gig, another 64 gig, 64 gig. Once the chunklets that you're using once the chunklets for a CPG are allocated, are 95% used, we allocate another amount of chunklets based on this growth increment. Then we use those, and we use another, then we allocate another one. So this growth increment determines how much space will be allocated when it's needed for the volume sharing a CPG. All right. So you can tweak the growth limit, but keep the defaults normally. I mean, lower growth increments allocates less space at a time. But the lower growth increments means we're have to allocating more chunklets on the disks. That's more backend on the disk. So it's kind of a trade-off. Keep the default. Normally you want to keep the growth increment the default. By the way, since I'm on this slide here, all right, remember this slide, I kind of was, these are my chunklets, these are my regions and so on. So if these are my chunklets that are kind of owned, if you will, by a CPG, remember that these regions these chunklets can be owned or are owned by the CPG. In other words, see these purple squares? Those represent like the pages, the 16K pages for a volume. If I create another volume using this CPG that's black, this volume here, that's the black volume, can use this chunklet as well, right? Mirrors, parodies, and so on. These represent the 128 meg region. Create another volume in green here using this CPG. It can, start 16K, mirrors, parody. These green volume can use these regions. So these chunklets can be shared, if you will, by the volumes in the CPG, but essentially this purple volume a region is kind of owned by a volume. In other words, this purple volume can't write into the black volumes region, and green and vice versa. But if I have another CPG, that CPG is using other chunklets. These chunklets can be used by the volume sharing a CPG. So chunklets are owned per se by a CPG. The volumes can share the chunklet. So that customer that said, well, I create a 1 gig volume, that's chunklet is, my data is going to, no, because multiple volumes sharing a CPG can use the chunklet. And then eventually these chunklets are grouped together into a logical disk. And then this logical disk is assigned to a controller node, right? So essentially your LDs and all your chunklets and regions are spread across all your 4 controllers. So CPG is very important. And I know with 1S, I know that right now I think you've got some RAID 5 CPGs, some RAID 1 CPGs. I don't think Bank of America is using RAID 6. And, I don't see customers going crazy with thousands of CPGs, They have, the default CPGs. They create certain CPGs with tweaked characteristics, or maybe a CPG for this client or that client, or, but I don't see people creating thousands of CPGs. But the CPGs are important conceptually because they are the policy that determine a volume's RAID level, set size, everything we talked about, that have cost, performance, and availability ramifications. So any questions on CPGs? All right. So once you have these CPGs, you got your default CPGs, you're ready to create volumes. So there are three types of volumes: the fully provisioned, the thinly provisioned, or the TPVV, and what you're using, the thin deduped or deduplicated thin. It's basically a thin provision volume. It has all the characteristics of a thin provision volume, but we're going to dedupe on top of it. Let's talk about first the fully provisioned. And there are some advantages. There are pros and cons. The fully provisioned volume is, you create a volume that's RAID 1, RAID 5, whatever the size, and the space is allocated up front. Now, the bad news with fully provisioned is, think about this. Let's say a DBA comes to you, or an admin comes to you and says, I need 4 terabytes for this database. Well, you can give it to him right away. You're going to allocate the space, but you're not going to use that. He's going to grow into that space, right? 4 terabytes is going to grow, database grow. So the disadvantage of fully provisioning is that you might overcommit. You're basically allocating space up front that you may not use right away. And that's a cost disadvantage, right? That's the disadvantage of fully provisioning. Now, the good news with fully provisioned is, the space is there, so you won't run out of space. So the fully provisioned good news is the space is there, it's allocated, you're not going to run out of space. But the downside is the cost. So one of the hot, I guess it's not new anymore, but over the past 8-9 years, space guaranteed, you're not going to run out of space. So fully provisioned has some advantages, right? Fully provisioned has some advantages. So now let's talk about just thin provisioning in general, and then we'll get to dedupe. So you can create what's called a thin provision virtual volume, or a TPVV. With a thin provision volume, you create a volume that's thin. Like here, they create a 100 gig volume. They export it to the host, to this host here. All right, so it's a virtual amount of capacity. The host sees a 100 gig disk, right? But as the host starts writing to the volume, the space is allocated on the fly. These little squares in black, green, and black, red, and blue here represent the 16K pages into the regions and the chunklets. So essentially, remember, the space is allocated for the volumes using a CPG. Really, the chunklets are allocated based on that growth increment. Then they're used by the volumes. The volumes use the regions on chunklets that are assigned. But basically, the nice thing about thin provision volume, the advantage is, we're allocating space just in time, just enough. You could oversubscribe, right? So essentially, you can create thin provision volume and exceed the amount of capacity you have. Let's say a customer only has, 200 gig of SSD capacity. They could create volumes exceeding that amount, and then down the line add more disks, right? So you can overcommit or oversubscribe, which is cost, right? Cost advantage. Now, the other thing, when you hear me turn, what's the downside of thin provisioning in general? Good news is cost, right? What's the downside of using, say, thin provisioning in general versus fully provisioned volume? Anybody? You could type. Yeah, Manoj? No?
Yeah, can you listen?
Yep.
Can you hear? Sorry. So what happens is, in a complex environment, the total size of the thin provision volumes, the biggest limitation is that if the space starts getting filled up, you will end up, even bringing down the array, because then there's no physical space for the thin provision volume to grow. So it gets oversaturated.
Right. So the good news is you could overcommit, right? But the bad news is you could overcommit, and what if you run out of space?
Yep.
So it's going to involve more like Srikath, you mentioned, you're going to monitor the space more, make sure you're not running out of space, particularly if you overcommit.
Yeah, yeah. So,
You know,
yeah. So in the bank, we do this for our VMAX arrays, and we have couple of mechanisms to monitor it. We do it at the array level, and then there are standard limits under for a volume to be overcommitted, or even the pool. A similar concept like CPG we have is a pool, thin pool. So we oversubscribe to a fixed percentage, and then we monitor it regularly every day, every 6 hours kind of thing.
right, right, right. So, Ron, did you have something you wanted to add to that, or were you basically going to say the same thing?
Yeah, Manoj pretty much covered it.
Okay. So, if we just kind of compare, just generally speaking here, if I'm comparing fully provisioned versus thin, particularly if you overcommit or oversubscribe, you could run out of space. That's basically it. So there's more monitoring. What if you run out of space? The other thing too, though, when you hear this term overcommit or oversubscribe, you often think about it in terms of, you run out of space. But the other thing you want to think about is, we just talked about, is, this growth, let me flip back on it, this growth limit. Like if you have a growth limit here set to be 40 gig, you can create volumes that exceed that amount. Like let's say I create 4 16 terabyte volumes. So I've overcommitted. I export these 4 green volumes to my host. I start writing. And then, when we hit the growth limit, what'll happen is basically whatever the OS is here, they'll get the equivalent of write fail or disk full. So when you think about oversubscribing or overcommit, you think about oftentimes running out of space. But also, what if you have a growth limit set and then you hit the growth limit for the CPG? All right. But the good news here with thin is the cost advantages, right? And I know that you're doing everything thin. So just in general, the thin provisioning in general is, it's on the fly, no upfront. We have no performance impact. Like if in other vendors, there could be a slight performance impact on what we call initial allocation, because you got to allocate some space on the disk and then go from there. But with all of our benchmarking and testing, there's no performance impact with a thin provision volume, just basically because our page size is so small of 16K. There are no restrictions where you can create the thin provision volumes or the thin deduped volumes. Like in other arrays, you may not be able to make a snapshot or remotely replicate a thin provision volume. You can use them wherever you want. You can replicate them, and they're just striped across all of the disks, using the CPG like a fully provisioned volume at the end of the day. It's just on the fly allocation, right? So those are the advantages of thin provisioning, but the disadvantage of thin provisioning in general is that risk of overcommit. What if you run out of space? Hit the growth limit. There are certain applications that are thin unfriendly, like systems with high file utilization, redo logs, small capacity volumes, smaller volumes, just create them full. They're, not a big deal. Environments that require encrypted or SAN encrypted volumes may not be a good fit. And not so much with deduped, but there's some additional hoops you might have to jump through. With VMware, it's not an issue. But there are some advantages. The main disadvantages, the main is if you run out of space. And there's some good candidates. I have some customers that just don't like the whole idea of thin in general. This virtual amount of capacity. I have some customers that may not apply to you. They don't like thin. They use they're 100% fully provisioned, but like I've worked with some government, I've worked with the U.S. government, a couple of agencies who have 3PAR, and in the government, in terms of procurement, like I've worked with some of the, not with the Department of Defense, organizations within the Department of Defense, and there's a concept like within the government, like if I charge back an organization for 8 terabytes or charge back for procurement purposes 8 terabytes of space, to a cost center. It has to be real. It can't be this virtual stuff. So, you know, maybe legally, or like even, let's say I have a client that's paid me for 4 terabytes. I probably want to give them 4 terabytes of space, right? If somebody's paying me for 4 terabytes, not this virtual amount. So there are some use cases where fully provisioned, you might want to use them. Okay. But the downside of fully provisioned is the cost, which is, you're talking about essentially the cost of utilization. All right, so you can create a thin provision volume. Now, let's talk about thin deduplication. Now, from here, what I want to do here is let me find it here. I have a whole kind of chapter. It's actually pretty short on dedupe. So what I'm going to do is shell out from kind of the topic in your book to this chapter called thin dedupe that I use in another class. But by the way, if you go into that that share I gave you, you'll see a zip file out there. It's called dedupe.zip, and it has the this slide I'm going to use. So a thin dedupe volume, this is a new feature, a little bit of an introduction. As deduplication has become increasingly important with the acceleration of use of SSDs in the disk arrays. To reduce the cost ramifications associated with SSDs versus nearline and NFC, solutions like dedupe and compression can reduce the cost of your SSDs. And what we're going to do is eliminate the duplicate writes, the 16K page writes. The whole concept of this, now remember, deduplication, you can only create what we call a thin deduped volume on SSD capacity, not FC or nearline capacity. So essentially, it's a thin provision volume. It has all the characteristics, if you will, of a thin provision volume. It's a virtual amount of capacity. The space is allocated on the fly. It's like a thin dedupe volume. But any 16K page that has duplicate data won't be written out there multiple times, but I'll give you some specifics here as we move on. By limiting duplicate writes, we're going to save, we're not going to, that saves space on the SSD, the more sensitive media, and also we're not banging the disks as much, so it's going to hopefully extend the life of the SSDs. It's supported on your 7440. You have to have SSDs, and we only do it on SSD volumes. You have to be running through PARS 321, which you are. You can work with an SSMC. You don't need additional license. And there's really no performance ramifications from all our best benchmarking and testing with a thin deduped volume. Now, a couple of details. Let me give you a little bit here. Let's say I have a CPG created. Let's call it CPGX. And then here's a CPGX. And of course, the CPG has to be created using SSD volume or SSD disks. But whatever the RAID level is, it's SSD RAID 1 here. And from this CPG, you can create what we call thin dedupe volumes. Let's say we create thin dedupe volume 1, a second one, TDVV2, and a third one, TDVV3. Okay? So these are 3 thin dedupe volumes created from an SSD CPG. Now, by the way, from this CPG, you can also create fully provisioned volumes. And even thin volumes that aren't deduped, just a regular thin provision volume that we're not going to dedupe. So in this CPG, you can have a mix of thin deduped, fully provisioned, and thin provisioned volume. But with the volumes that are within this CPG, like these 3 thin dedupe volumes, let's assume these 3 volumes here are exported to 3 hosts, 3 different hosts. And so remember, as I said a little bit earlier, eventually for these 3 volumes, the hosts are writing, and we've got to, eventually take those 16K pages and get them down to disk. So amongst the thin dedupe volumes that are using a CPG, if these pages, let's say this page here had the data 00A in it, this page here, that's written down to disk. As another volume or the same volume sharing a CPG writes the same page, let's assume this page here, and remember this has been written down to disk here. This has been written down to disk. This top page has been committed to disk. If another write comes in, contains what we call duplicate data. It's already been written out there once. It's not going to be written a second, third, fourth time. So details to follow, but we're going to essentially duplicate at the 16K page level for all the volumes sharing a CPG. Now, that being said, let's say I have another CPG created. This is called CPG 123. And it's, an SSD CPG, RAID, whatever, RAID 6. Let's say I create some thin dedupe volumes using this CPG. We're only going to compare the 16K pages for the volumes using a CPG. In other words, let's say a volume using this CPG up here, we got a 16K page that contains the data 00A. Well, that's been written in volume down here using this CPG. This is a different CPG. This will be written out there a second time. So we're only going to compare the 16K pages for the thin dedupe volumes using a CPG. Like if this volume's up here and this volumes have duplicate data, we don't compare. So we're going to create a thin provision volume. What happens when you create your first thin provision volume using a CPG, and this happens behind the scenes, you don't have to create this. You create a thin dedupe volume. What happens is we create what's called a dedupe data store for the CPG. When you create your first thin dedupe volume using the CPG, it'll be created when the first TDV is created using an SSD CPG. The dedupe data store is used to hold the data, both unique and duplicate, for all the TDVVs using a CPG. Only TDVVs using the same CPG are compared at that 16K page level. And if you do a command like, I know I wrote over this, there's a command called show VV. You'll see a file out there called .sysvv_0 with the CPG name, but it's not usually visible out there with standard show VV output. There's an option you have to use to drill down this, but there's a duplicate data store that's created. Okay, and what we do, let's read a couple of things. Inline deduplication with instant metadata lookup. Now what they're saying here is it's the ASIC that's going to be doing the deduping. It's inline. Okay, so the ASIC, we use the ASIC. We use something called express indexing to look for what we call metadata lookups to compare for duplicate pages. We do the bit by bit comparison, and we create a signature. We do it at the 16K page level. So you could actually do all of your 100% of your capacity. So there's no limit. And in fact, I know that you're basically, everything is 100% deduped. Your SSD 100%, you're doing thin dedupe volumes. Right.
Okay, so this is, I'm sorry for interrupting. This is on and we got a general question of the scope of deduplication.
I'm having a hard time. Give me a second. I'm having a hard time hearing you. Am I on speaker or I'm having a really?
Yeah, I got you on
Okay.
speaker.
Okay.
Yeah.
Okay. Good. That's much better.
Oh, sorry. I was above this microphone. Now I'm right even with it.
Okay.
The general question is this. So the scope of the deduplication, is it, my impression is then it's only whatever's currently in memory, not what's actually written to disk?
Well, what's happening, let me kind of here, let me kind of flip to this slide. It's actually, because remember, as the host writes, remember in our cache, we've essentially got those 16K pages. We got to pull them from disk into cache. These represent those 16K. Oops. What we call cache management pages. So let's say a host writes. Here they're basically saying the host writes this page. This gray square represents a page. But actually what happens when a host writes to any volume, we have to pull the data from disk, from a 16K page from disk into cache. And then this is referred to as a 16K dirty page in cache. So what happens eventually, this host writes this page into cache that contains the data in this example 00011101. All right. So what happens
Threat has been detected.
is the ASIC, remember the ASIC handles the data movement for any volume, parity calcs, reading and writing from cache down to disk. But the ASIC computes a hash and uses something called express indexing and a metadata, a lookup table. And what happens as the write, see, this is a page that essentially is going to have to be destaged to disk, right? It's in cache. We've got to write it down to disk. What happens is we use this metadata table lookup. If this page here, which contains the page 00011101, that's the data. If that is essentially already written out on disk, this is the page on disk. So we're trying to write this on disk. It's already been written out there once. For this volume or another volume from the same CPG for this volume. If we have a match, this is what we're trying to flush down to disk. In red here. It compares what we're trying to destage versus what is out on disk. Just a second here, Ron. I see your hand up. What then happens is an XOR operation is compared what we're trying to flush down from cache down to disk. It uses that duplicate data store. This is essentially out on disk. What then happens is the ASIC does what's called zero detection. Now, zero detection usually applies to just thin provision volumes, not dedupe volumes. What actually happens is on a match, if this 16K page in red here we're trying to flush down to disk, there is a match. This ASIC zeroes out the page, and the ASIC then does what's called zero detection. And then what happens with zero detection is the ASIC is not going to write to disk any 16K page that contains all zeros. So basically compares what's out on disk. It's a match. It zeroes out the page. This ASIC does zero detection, discards it, and won't write it a second, third, and fourth time. Okay, so wrong question.
So the scope is the volume that you're writing to, or is the scope the entire array?
The scope we're looking at, essentially, or this is looking at, it's looking at, again, the volumes sharing a CPG.
Okay, so if I have 12 volumes sharing a CPG, then those volumes represent the patterns that you're looking for.
Right.
Okay.
So in my example here, I had 3 thin dedupe volumes. They all writing page, 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 page. Now, if all 3 of those volumes started, so this is actually at the page level for the volumes sharing a CPG. So I have other volumes, different CPGs, different CPG, and those, write this page, and it's not a duplicate for that CPG. It'll be written to the disks another time. So it's not per se at the array level. It's at the CPG level, the volume sharing a CPG at that 16K page level.
All right, cool. That was the key. That was the overall question, was the scope. So I could have,
Yeah.
5 1 terabyte volumes in the CPG, or
Yeah.
500 terabyte volumes in the CPG. The total amount of space that's deduplicated will be dependent upon what I scoped into a single CPG.
Right. Right.
Okay, cool. Thank you.
Exactly. So usually if you want to, like you're saying at the array level, well, let me kind of jump here. I know I'm jumping around here. This is a little about the indexing, and this I just kind of went over. One of the things, there is a 256 thin dedupe volume per limit per CPG. That may not be a limit you'll ever run into, but like if I have customers that, have thousands of thin dedupe volumes, you can only put 256 thin dedupe volumes in a CPG. So if you had two different CPGs, we're just comparing the 16K page for the volumes in a CPG. So as long as, you're not going above that 256 TDVV limit per CPG, everything is essentially going to be compared. If I have customers that have 100 thin dedupe volumes, they dump them all on CPG and everything is essentially compared. Because remember, the other thing too, like Ron, you're saying at the array level, I mean, in your case, your array is 100% SSDs, right? But remember, thin deduped can only be done for SSD volumes, right? Not FC or nearline. So you can't even create them, thin dedupe volumes in FC or nearline CPGs. So it is at the SSD level, and the volumes within a CPG are compared for that 16K page duplicate, essentially.
Right. So yeah, just let you know that, I mean, the high level use of this for me is I do a lot of multi-year planning, and and actually based on whatever engineering's come up with for our standard configs, and right now, of course, the standard config is SSD. And based on what you've told me here, it helps me better plan out our 3-year volumes and things like that as I look to it.
Right.
That's why I asked the questions I did.
Right.
And then, of course, then there's the question of the all magic numbers of how much is something dedupe, and that,
Right.
of course, always varies. So,
Right.
anyways, cool. But thank you. This tells me everything I need to know, and I thank you very much for
Well,
explaining that.
and that's the other thing too. I mean, some people ask me, okay, here, let me give you some general questions. Like it may not apply to you guys, but people ask me, remember, with SSD volumes, you can just create a thin provision volume. It doesn't have to be deduped. And some people will say, well, why wouldn't I want to dedupe it? Right? Because there really isn't any performance. I mean, there is a little bit of overhead. Everything we got to do a match. I wouldn't say that's the anything we got to do like check for the 16K page duplicates. That is a little additional overhead. But from all of everything we benchmarked and everything, we don't really see a performance hit. But people will say to me, well, why would I just create a thin provision volume on SSD capacity, not thin dedupe? Well, we say, well, maybe the data has been, deduped on some sort of front end process, right? Or it doesn't have a duplicate affinity in the first place. Don't dedupe it. Or when you've got these CPGs, we talked about CPGs, volumes sharing a CPG that are thin deduped, do they have a duplicate affinity or not, right? I mean, maybe in one CPG you'll dump volumes that you suspect might have duplicate an infinite affinity. Or another CPG, they have another type of possible duplicated affinity, there, and you have to work with those numbers as well. But the other type, the other thing, and this won't apply to you guys because you're not using a feature called adaptive optimization. There's a feature called adaptive optimization we have that allows our customers to have a volume spanning media types. Like a volume could eventually span FC, nearline, and SSD capacity. Well, you're not going to use that feature because you're 100% SSD. So you're not going to use adaptive optimization, but you can't do AO on top of a thin dedupe volume. So some of my customers who are using adaptive optimization don't want to, you can't use both. On the array, you can use both, but a volume can't be set up for AO and deduped at the same time. So they create it thin. So So yeah, that's a little bit about the dedupe. Here are a couple more things in terms of the dedupe, then deduped. We haven't, one of the things, and I probably won't get in this to a lot, I will a little bit later on, because with with what happens with the general thin provision volume, as I just kind of mentioned, there are a couple of use cases. With the thin provision volume, this ASIC is going to do zero detection. And with a thin provision volume, not a thin dedupe volume, it does what's called zero detection. Now, eventually, for a thin dedupe volume, this ASIC is a player, it's zeroing this page out and then doing zero detection. But with the thin provision volume that's not deduped, it's possible a page could come in with zeros and this ASIC would discard it, not write it. So technically speaking, for a thin dedupe volume, we don't do kind of the same, it's not really applicable in terms of zero detection like a thin provision volume. But over the course of time, particularly with thin provision volumes and even thin dedupe volumes, pages, as volumes grow or are deleted, it's possible that that duplicate data store could accumulate pages that have no reference as they grow and delete and so on. So there's what's called a garbage collection process. It's called a GBC. This is a system process that goes out to the data store that contains the duplicate. And if there are any 16K pages that are unreferenced, it pulls them back to be used for the CPG for other volumes and so on. So it's called the garbage collection process. It's a system process. You don't have to worry about it. This goes on behind the scene. But the other good news is, keeps the thin dedupe volumes thin. Brad pulls the pages back in if they're unreferenced. Couple of things we've talked about this. Only thin provision volumes from SSD can be deduped. You can't use AO on top of it. We do that 16K page level, so it's best where IOs are aligned to this granularity or multiple of 16K in terms of the IO, incoming IO. Again, it's done on the CPGs only. For maximum efficiency, store data with duplicate affinity and TDVBs using the same CPG. It's great for redundant data. Data that has been previously deduped or encrypted are not good candidates for dedupe. We don't do compression, by the way. That's coming. So to create a thin dedupe volume from the command line, you do create VV minus TDVV. And in SSMC, actually, this is an excerpt from Management Console. Let me just skip to this. In SSMC, when you create a volume, and I showed you this a little bit earlier, I stopped, but remember I showed you earlier how to create a volume, you give it a size and so on. And if you have SSDs in your array, the provisioning type is deduped, and then you choose a CPG, right? And you have to choose an SSD CPG, and the pull down will show you SSD CPGs. Here's just, I got some examples from CLI. Show VV, this is a thin dedupe volume. This is a fully provisioned volume. These are some simple examples. Now this one here is nice to know about. When the feature thin dedupe came out in 2014, we changed a lot of our screens in SSMC and a lot of the output from the command line, like show VV, show CPG. And like this example, they do a show VV minus space on 3 volumes. And when the feature dedupe came out, we changed a lot of our output to display what's called a dedupe ratio and a compaction ratio, these columns. This is applicable to a number of CLI commands. And by the way, if I flip around here in SSMC, you'll see what's called a compaction and the dedupe ratio. So if I flip back on this example, this column here in compaction actually shows you the savings you're getting from doing thin in general. All right. So this is called the compaction ratio. It's not compression. This is really the space efficiency you're getting from doing thin. So like, let me show you this. Let's go over this example here. This first volume here called VV1 is a thin provision volume. It's not a dedupe volume. These two are thin TDVVs. These are thin dedupe volumes. So this is just a thin provision volume. So clearly it's not going to have any dedupe because we're not deduping here. But the thin provision volume size is 100 gig, and you can see it's used 10%. So this is actually showing you the percentage of the thin provision volume that you're using. And the way I like to say this is this. When you look at this compaction percentage, I like to think of it this way. You're like, for this volume here, it's 10.0. If this volume were a thin, I'm sorry, if this volume here were a fully provisioned volume, you would be using 90% more than what you're using, right? If this were fully provisioned, you'd be using 100%. You'd be using, since it's thin, you're using about 10% of what you would have been using versus if it were full. And of course, this compaction savings you're getting for thin is going to show up for thin and thin dedupe volumes here, and then it gives you some totals here. Now, this dedupe ratio is only going to show up for thin dedupe volume. If you see a dedupe ratio of 1 to 0, you're not getting any savings from deduping. In other words, there's no duplicate data here. So when you see a dedupe ratio of 1, you're getting some savings from doing thin, but there really wasn't any dedupe data out there, so you're not really getting anything. But when you see a dedupe ratio, like in this volume VV3 here, it's thin deduped, you're getting a dedupe ratio of 2 to 1, or 2 to 1. You are getting savings from deduplication. So here in this dedupe column, you're getting essentially the savings you're getting by doing dedupe. Now let me explain this. So we're working with these two volumes here, VV2 and VV3. I actually set up this little demonstration here, well, demo here to kind of do this example. This volume here, VV2, I exported to a Windows host, and I mounted it with a file. I had a file. It just had one file, didn't have any dedupe data in here. Right, so it was no duplicate. Then I took this volume here, VV3, and exported it to a host, and it was a thin dedupe volume. Then I put a file out there. I mounted it, put a file out there. Then here's what I did. The file was called file A. I went in and renamed this file. And then I copied file A out there again. So essentially, these two files had the same data. It was a simple thing to do. I, renamed a file and copied it out there again with this different name. These have different names. So I got a dedupe ratio. So this is telling me that the ratio you're getting, savings you're getting essentially from doing dedupe. A couple of the other examples show CPG minus D. Here they show CPG minus D. D is for detail on a CPG. This is an SSD CPG. Here you just see you've got 3 dedupe volumes, TDVVs. This CPG here has just some thin provision volumes as well, but there's another example. Show space. Here they do show CPG, show space minus CPG asterisk. Show me all my CPGs on my array. Just to show you that this CPG here must have thin dedupe volumes, and they're getting a dedupe about 60% here. Compaction savings from thin in general. Here's from the in SSMC from the dashboard. You'll see the dedupe savings. Like here's the dedupe ratio. If they wrote 30 gig, 20 gigs worth of savings, there was a lot of dedupe. This is just kind of an example They do a show sys minus or show sys minus space. This is a command you can run to look at all the system space on your array. Give you some numbers and then compaction and dedupe. Here's another example. This one here is SSMC off to the left, showing you your capacity efficiency from the dashboard area. Dedupe. Now the other thing too, and you're probably not going to do this, is now this, by the way, this screenshot here is an excerpt from Management Console, not SSMC. In SSMC, well, what I'm talking about here is there's a way you can do what's called a dedupe estimate. So let's say I have a customer that has a thin provision volume and they want to, let's say the thin provision volume is allocated from FC capacity to nearline capacity. They want to do a little estimate to see, if it was thin deduped, what kind of savings they would get. So like back here, this is volumes are exported to host. They're choosing 3 volumes that are thin provision. They're exported to a host, and they want to do a little estimate on it. So when they do a little estimate, this is in Management Console. It's pretty straightforward. And then what will happen in Management Console, you can get a little estimate here. If they were thin, what would be, if they were thin deduped, what would they be? What would be the savings? You can also do this dedupe estimate from the command line. You check VB minus dedupe dry run, string out some volumes. It'll start a task. Then you can do a show task using the task number and get the estimated savings you would get if they were deduped. And then from there, you can convert your volumes from thin to thin deduped. Now, you're not going to do this because all your volumes are thin deduped already. But the point is, for our customers who do have thin provision volumes allocated from SSD or nearline, and they say, well, I want to see, is there duplicate data out there? I could do a little estimate and then convert them to thin deduped. Now, to do the estimate, and I know you're probably not going to do this, the dedupe estimate that I just showed you from the command line and from Management Console, you can't do an estimate in SSMC right now, but you will be able to in the next release of SSMC 2.3. Then you can convert, if you want to, and you can convert from the command line as well. So our snapshot, we haven't talked about snapshots or clones, so I'll hold off on this until we talk about snapshots. So it's a little bit on the dedupe process and volumes in general. Okay. All right. Okay, let's do this. It is about it's almost 11 o'clock. Let's take a quick 10-minute break and we come back and we'll go over a few more things and then we'll take it from there. See you in 10 minutes. Okay, everybody, this is John, and I am back. Go ahead and put your hands up out there in the virtual classroom if you're out there and can hear me. All right. So after talking about volumes, CPGs, Thindy Dupe volumes, this chapter won't take too long. We're going to talk about storage configuration. We're going to show you how to work with it from the command line, and I'm going to show you how to work with both CPGs and volumes using SSMC. So the CPG, in SSMC, you're going to be in the, from the mega menu, common provisioning groups. Here, you can see all your existing CPGs. Just to show you this, you can create a CPG. Now, a couple of these things I'll go over a little bit later on, but first I'll show you how to create a CPG. And when you create a CPG, I pretty much showed you this, right? You choose the array, or I'm sorry, you give your CPG a name. Now, in terms of naming convention, when you go into, if you go into SSMC, you see your CPGs, and by default, you can look at the details and change your view here. But in terms of naming convention, if you do create CPGs, you can name them whatever you want, but normally you want to call them some sort of name that signifies the CPG, like, SSD RAID 1, set size of 8, HAK, some sort of naming convention. So when you look at the name, you know what it's about. So you give it a name, but you can call it whatever you want. Choose the array, and you're not going to be using virtual domains. But then, like we showed you, you choose the device type, the RAID level, the set size. The default is HA cage. Jumping around here, I showed you the growth increment, the growth limit, and the growth warning. The little, do you want to display usable space for the CPG? And then you create it. And then from there, you can highlight your CPGs. You can change your views, get the settings. Like here, you're in the settings view, and you can see the growth. And they highlighted this CPG, and it's RAID 6, magazine, et cetera, et cetera. And then from there, let me flip back here. When you highlight a CPG, or in this area, you can create new CPGs. Now you can delete a CPG, but the CPG has to be empty. In other words, if there are volumes or snapshots using a CPG, you have to delete the volumes. You do have another choice. You can move volumes from one CPG doing a DO tune, but I'll talk about that tomorrow. So you can delete a CPG, but it has to be empty. You have to move stuff. You're doing a DO tune to another CPG or delete the volume. You can, one of the things, you might want to refresh the capacity efficiency to update the numbers here. Compaction we'll talk about later on. Particularly with Thindy Dupe volumes, we do a good we do a decent job of reclamation for Thindy Dupe volumes. So compact essentially goes out and takes any pages and reformulates the logical disk more effectively and compacts it. The one I want to point out here, though, is this edit. You can actually edit a CPG, but in SSMC, you can only edit like the set size. You can't edit the media. You can change the name. When you edit a CPG, let me kind of go to this screen. When you edit a CPG, you basically get this screen, but you can only edit the set size and the availability option. You can't edit the media type, the RAID level. You can play with these settings as well, as the growth limit. So when you edit a CPG, you can't change, you can change the name as well. But one thing, you can change a couple of things, but when you edit a CPG, like let's say you have a RAID 5 CPG, you go in and change the set size. When you edit a CPG, it will only impact new volumes. So let's say I have a RAID 5 CPG set size of 4. You go in and edit it to set size of 6. Well, any new volumes you create would be RAID 5 set size of 6. There's a second step. If you want to edit the CPG and you want that edit to kind of impact existing volumes, you have to do a DO tune, which we'll talk about tomorrow. Just know for now, you can edit a CPG, you can edit a few things, but there might be a second step you have to do to have that edit impact the existing volumes. So here are your different views, CPGs. This is all management console stuff. I'll skip that. You can work with CPGs from the command line. The key command is create CPG. You can use -T, R5, R6. The default is RAID 1 CPG. Here they're doing an HA mag. They must not have enough. And then you name the CPG. HA mag, the default is HAKH. By default, when you use the create CPG command, the default media type is FC. So if you want to create an SSD CPG, you have to say -dev type SSD or -dev type nearline, eventually give it the CPG. And here in this example, they're just showing you here, you can use the growth limit and the growth warnings here. Here, just another example, if you want to play with the set size, it's -SSC, set size, dev type, the RAID level, -T for type, media types. How many of you played with the command line yesterday? Did some of the show commands I had you do? Nobody? Okay. Well, just to let you know, as we move forward here, I believe that from my past teachers with Bank of America, most of the admin's going to be done using SSMC. But it's nice to know about the command line. Because you can create volumes, create hosts, export, DO-tune, snapshot, everything using the command line. But just to kind of say this, I'm going to give you, as we move forward here, some of the key commands. Like to create a CPG, the command is, create CPG. I'm not going to go into, in most cases, as we move forward here this week, every option, every command. We're not going to go over every option, every command. I'll give you some highlights. So you can use create CPG to create a CPG. You can do show CPGs to show your CPGs how many volumes. You can do show CPG, give it a CPG name. Here they do a CPG, see how many volumes and space numbers. To edit a CPG, it's set CPG. And to remove a CPG, it's remove CPG. You can string out multiple CPGs if you want to remove CPGs. The nice thing about the command line is you can use wildcards. Their naming conventions are important. Again, with removing a CPG, it has to be empty. For volumes, SSMC, you're going to be in the volumes area to create a volume. And, you give your volume a name, choose the array, thin deduped or fully provisioned. You're going to be doing thinly deduped mostly. You choose the CPG. Now for thin deduped, you're going to have to use an SSD CPG. There's all the CPGs you're going to have anyway. You don't have any FC or nearline. Then you give it a size. Remember the size. The biggest volume you can create is 16 terabytes in three parts. 16 terabytes. Now, if you read documentation, they'll tell you that you can create a 256 meg volume. But in your case, that's some of the older arrays, remember, with the 256 meg chunklet. So your smallest volume can be a gig up to 16 terabytes. Oops, terabyte. When you give it the size. The other thing I should have mentioned when I was working with it, showing you the CPGs, there's a little advanced options button up in the corner. If you don't click you got to click advanced options when you're creating a CPG to be able to change things like the set size and the availability options. By default, these don't show. So with the virtual volume, when you create a volume in SSMC, my examples here, I assume you clicked on the advanced option button to show everything. Now, so when you create a thin provision volume, yours are going to say thin deduped. But when you create a thin or thin deduped volume, you can actually set up what's called an enable. By default, it's disabled. You can enable and set what's called an allocation warning. And this is expressed as a percentage. So let me change the example here. Let's say you create a 10 gig volume and you enable the warning to be 85%. Well, let's say this volume is exported to host. Once 8.5 gig or 85% of this is used, because it's thin. Now this applies to thin or thin dedupe. Once it's used, 85%, an alert will be generated with this allocation warning. Remember when we talked about CPGs, you can set a growth limit and a growth warning at the CPG level, but this is at the volume level for thin provision volume or thin dedupe volumes. But you can also set what's called an allocation limit. You can do either one of these or both or neither. But if you set a limit, like here it's expressed as the percentage is 90%. So let's say I export this 10 gig volume to a host and I cap it off to be 90% or 9 gig. Once the host writes 9 gig of capacity, it'll be fenced off from new writes. So you can even though this host sees a 10 gig disk, once they use 9 gig of it or 90%, it'll get the equivalent of basically write full disk fail. This isn't used a lot. One thing you can do though, I mean, some people do this, like, let's say my client is paid for 9 gig. You can create the volume 10 gig, cap it off at 9 gig, and then later on go in and edit it and take this limit off once they pay you for another gig. But you can set a limit as well for thin or thin dedupe volume. And see, these two screens kind of go hand in hand. When you create a volume, this is all on the same screen. Then you create, when you create a volume, there's an area called the allocation settings. And if you click on this edit button, you can set up for the volume you're creating what's called the copy space. Now, when you create a volume, let me flip back. You're supplying the CPG for the volume you're creating. This is what referred to as the user CPG for the volume space. If you want to make a snapshot off of this volume, you have to define what's called copy space. Now, to this area copy CPG, and you can set a limit or a warning for the copy space CPG. This involves snapshots. We'll get to this tomorrow. If I want to make a snapshot off this volume I'm creating, I have to define what's called a copy space CPG, which could be different than the user CPG. In the lab today, I have you doing this. Go ahead and do it for tomorrow's snapshot lab, but we'll get to what this means tomorrow. Now, the other thing down here too is you can, in the volume grouping area, the default is to create one volume. So here they want to create a 10 gig volume or a 4 gig volume called TPVV_14. The default is create one volume, but if you do a number of volumes here, you can give it a count. So like if you want to create 3 4 gig volumes, you can create 3 4 gig volumes. Or you can give it a count. You can create more than one volume. Now what will happen though when you create the volume, see this example, they're naming the volume TPVV_14. So if you do a count greater than 1, and you can do up to 99 volumes as long as you have the space and so on. Remember on my prior screen I said create the volume TPVV, I don't remember now, it's TPVV_14. I said create the volume TPVV_14. Now, if I said here, create 3 volumes, the volume names, the 3 resulting volume names will be TPVV_14.0, TPVV_14.1, and TPVV_14.2. So if you do a count greater than 1, it takes the name of the volume you supply here and appends a .0, 1, 2, 3, etc. like that. Now, if you do a count number of volumes, what we call a count greater than 1 here, there you can put a volume in a volume set, or put the volumes in a volume set, or even if you create one volume, you can put it in an existing volume set. We'll talk about host sets and volume sets probably tomorrow. So you can give comments, and then actually, then from there you can export the volume. If you want to, here we're creating the volume, right? Click on add, it'll show you a list of the hosts, and you can choose the host or host set. And we create a volume, there's a section called policies. And policies area here, there are a couple of things. Skipping around here a little bit, you can set what's called an expiration time and a retention time, but this requires what we call the virtual lock feature. And the virtual lock feature, you need a license to do this. Allows you to take a volume out there and give it a retention and expiration time and say, okay, the volume can essentially mark it read only, so it can't be the data deleted or the volume deleted after a certain period of time, and it'll expire after a certain period of time and be deleted. This requires the virtual lock feature, which you're not going to, you don't have that license, Bank of America. So in fact, since you don't have the license, this won't even show up in your case. Now, zero detect by default is enabled, but this applies to thin provision volumes, not fully provisioned or thin dedupe volumes. Now, remember, with thin dedupe, the ASIC is a player and computing that hash and does the, comparing the pages. And eventually the ASIC zeroes out a duplicate page. But per se, a thin dedupe volume, zero detection is disabled. So this zero detect is enabled by default for thin provision volumes. And in fact, with the thin dedupe volume, this won't even show up. Now, when you create a volume or volumes, the export policies allow you to export it to more than one host. But if you click on this, it'll change it to what's called restrict access to one host. So by default, when you create a volume, it could be exported more than one host. Default here, but you can change that. You can have some play with, each volume has a volume ID. Default is using auto ID. This stale snapshots we'll talk about tomorrow. But then from there, you create the volume with the create button. Now, this little create plus will create the volume and just leave the screen up there where you create another volume and so on. Now, let me flip around here. So you can see your volumes here. When you highlight a volume in SSMC, you can create a volume, create another volume. Create another volume. You can edit a volume. Now, when you edit a volume, you can pretty much change everything. Like you can, you can change the name. You can change, pretty much everything here. You can work with these settings. You can even change the size, but you can only increase the size of a volume. You can't decrease the size of a volume. You can pretty much change everything, like the name, these warnings, the limits, this stuff here when you edit a volume. The only thing you can't change is the CPG. All right. But you can edit a volume. Now you can increase the size of a volume up to the maximum, which is 16 terabytes. You can't decrease it. You can even edit a volume if it's exported to a host. So you can edit it. You can delete the volume. And you can even delete it if it's exported to a host, but a little pop-up comes up and says, are you sure you want to do it? You can export it. If it were exported, you can export it. Convert it means, remember I talked about you can convert a thin to a thin deduped or a thin to a full. This tuning here, this tune is the DO tuning I mentioned a little bit earlier, to do a DO tune, which I'll talk about tomorrow. In fact, with the tune, these all apply to the tuning. These are all, this is snapshot stuff we'll get to tomorrow. This is cloning and migration. And this is all management console, and you can use create VV to create volumes from the command line. Now, by default, this is important for you guys to know. If you ever do create a volume using the create VV command, the default is to create a fully provisioned volume. So if you want to create a thin dedupe volume, make sure you use the create VV minus TDVV option. Of course, you have to supply a SSD CPG, then you give it a size, a name, and any options. So remember that when you create a volume from the command line, it's a fully provisioned volume. You make sure you use the TDVV. Now, in fact, I mentioned this earlier. I said when I showed you that, or I mentioned when we were talking about the dedupe, there's a feature we allow you to take a thin volume and convert it to thin deduped, right? To convert a volume, and I said earlier, well, all your volumes are thin deduped anyway. You're not going to be able to, you're not going to convert them. But really, if you think about it, let's say you forget this, and you do a create VB, and you create a fully provisioned volume on accident with the create VV command, then you could convert it to thin deduped if you wanted to. So, but note that to use create VV, you use the minus TDVV option. And from the command line, you can, here's some options. You can do show VVs, use wildcards. This is an example I showed you earlier, show VV, show me my thin volume, and all of my volumes, including fully provisioned, thin deduped, some capacity numbers. This I showed you earlier, the show VV minus space. Here they do it on 3 volumes, the compaction dedupe ratio. Show VV minus host, show me all the volumes exported to the host DL36049. There's one volume exported. This is a nice command to know about show VV CPG. Show me all my volumes and the user CPG. Now there are a number of other volume type CLI commands. From the command line, you can do set VV to edit a CPG to increase the size of a volume. From the command line, it's grow VV. Give it the volume name and the size you want to increment it by. To remove a volume, it's remove VV from the command line. Okay. All right. So any questions on anything we talked about today? DPGs, volumes. Okay, it is about 11:12. Okay, so before we break here real quick, Prakash, yeah, thin dedupe is only supported on SSD currently. And why not on other drives? Well, the thin dedupe volume only came out in 2014, so it's been around a year and a half. And HP decided initially just do thin dedupe on SSD capacity. Now, that was a business decision. And one of the things, as I mentioned a little bit earlier, is, the thing about SSD volumes in general is, they're expensive. So, with thin dedupe on top of it, we're not writing pages out there multiple times. It's going to save you money on your more expensive media SSDs. So that was kind of the business decision for HP back in 2014. Right now, we're just doing deduping on volumes allocated from SSD capacity. So it's just a business decision on our part. Why not on other drives? Well, the reason it was done on SSDs is because SSDs are the most expensive media. I think really it's just business driven. The nearline disks are cheap anyway. FC is a little bit cheaper. But there is talk in the next couple of releases of at least doing deduplication on the 10 or 15K FC disks. But it's basically in market-driven decision. And probably at the time it was, you know, we wanted to do that first, and the other ones down the line we'll see with the other media types. But it is only supported for SSD capacity, which the good news for you is that's all you've got right now, right? SSDs. So, okay. What we're going to do, we're kind of at a good breaking point. We're going to take another half an hour lunch here, and then we'll be back at half an hour. So let's take a quick break of a half an hour. I'm going to put up a timer here for lunch, and I'm going to change that to 30 minutes.